So before we get into the main topic of today's video, I just want to say that if I do have a Discord where you can hang out with me or you can ask help. I'll link the two of them. The first link in the description, and it's just if you need help, you can come. If you're bored, need someone to talk to, you can also talk to other people. You can just join my hangout group. And there is one comment I saw. I think his name was Kadok. I forgot. It starts with a K, Kadak, something Cook. And he said, "Can I join your club? Can I friend you?" And I replied to him, "Yes." And I also left out that comment that I said that you don't need to ask to join, and that's the whole point. Why am I announcing this? That you do not need any You do not need to ask me in the comments that, can I join, or am I allowed to join? Is this only for smartos, or no? You can, whoever wants to join can join. Just, I don't allow bullies. But if you are a bully and want to join, you have to change, first of all. But that's not the point of today's video. Today's video is about Charles's Law. Charles's Law is somewhat similar to Avogadro's Law. If you have it, I'll put it somewhere right here. And it has the same format. Like, it looks kind of the same because it still has volume in it. So I'll just quickly get into it. So present, I have a 2-liter balloon, and I have a 4-liter balloon. This one's 200 Kelvin. If you don't know what Kelvin is just a form of temperature, and use K to represent it. And now, but I want to know, if this is 2 liters and 200 Kelvin, if it's 4 liters, if I pump another 2 liters, how hot would it be? Or how hot? And to that answer, you would write 400. It's common sense, alright? 400, and that's because since you're multiplying by 2 to get here, you also multiply 2. Common sense. Okay, that's kind of the main topic, but you want, in this, in Charles's Law, you're supposed to find one. Find either this one, this one, this one, or this one. So pretend we don't know the temperature of it, okay? Pretend we don't know what is the temperature. If I have a 2-liter balloon and it's at a temperature of 200 Kelvin, what if I pump another 2 liters? How hot would it be? Now you can use this formula. I'm gonna write in red. V1, oh, that's very small. I think this one? Yeah, V1 over T1 equals V2 over T2. I'm gonna circle it blue. That's way too much. So using that formula, so V1, you might be wondering, V1, what is that? Oh, that's volume. This is volume. So, and this is temperature. I'll put text boxes. Oh, temp. I'm just gonna write temp because I don't want to write temperature. And this is volume. Fine, there you go. Now you know the components. We're gonna do this question. So V1 is 2 liters, like you can see. So 2 over T1, which is temperature, and it's 200. And we're gonna equal to 4 liter, which is V2, and we're finding T2. What is this? I mean, what is this? To do this question, you're gonna cross multiply. So you multiply 4 with 200, 2 with T2. So 200, I mean, multiplied by 4 is 800. And that is equals to 2 times T2. And to find T2, you're going to divide 800 with 2, and that's equal to 400. So T2 is 400. And yep, we got the same answers as last time. And unlike most of laws, whenever it's like, for example, liters on one side, the other side has to be liters. But in this case, it cannot be. It can only be one side has to be Kelvin, the other side has to be Kelvin. If one side has Fahrenheit or Celsius, it won't work. So no, it doesn't work. It doesn't apply anymore. So it has to be Kelvin. Okay, the only unit Charles's law accepts is Kelvin. But then there is a scenario which you're only given Celsius, and I'm pretty sure you already thought of it, but you have to convert it. You're like, how do I convert it? I never learned it, but that's exactly why you're here. Okay, so TK, we're gonna use this formula TK. TK's the Kelvin, the temperature Kelvin equals TC, which is Celsius, and that is you're gonna plus 273.15. Trust me, okay? I looked at my notebook. It's hard to remember it, but since I'm teaching and I don't want to get it wrong, I looked at my notebook. And it's okay if you look at your notebook sometimes. I understand. Because I usually always look at my notebook for reference. Okay, it's not that. I mean, not that, I mean. So, TC is the one that you're trying to do. So, let's just say that this one's 20 degrees Celsius. So, we're going to use the formula. So, TC, so I'm going to write TK equals TC, which is 20 degrees Celsius. 20 degrees plus 273.15. Now that is equal to, TK is equal to, let me write the 0 better, 293.15 K. So 20 degrees Celsius is equal to 293.15 Kelvin. So that's just something to keep in mind. You don't need to keep it in mind, but it's nice, I guess. I'm not sure. It depends on you. I don't really want to remember it, but if you want to, you can. Oopsies. I need the answer. Okay, so now you got Kelvin. You can just write it down. 293.15 Kelvin. And you're just going to do the other one for liters. How much, how hot is it? And yeah, that's basically what Charles's law does. And if you want the definition, Charles's law describes the relationship between volume and temperature. I think you already noticed that, but this is how it is. And I think there's nothing else to explain. I mean, my notebook is... Oh yes, I have one more thing, okay? Okay, so if you also come to this problem where the units in volume are not the same. For example, one side is 2 liters and the other side is 2 millimeters. What are you going to do? Well, I would convert this one, the smallest one, into liters. Actually, it doesn't really matter. You have to, both units have to be same. So if this side's liters, this side has to be liters. If this side's milliliters, this side is milliliters. And once you're done to answer, if it's milliliters, you have to write milliliters. If it's liters, you have to write liters. And yes, you can also use this law to find the amount or just the temperature. And you also need to know the gas, because some gases, actually you don't need to know the gas. No, you don't. You don't need to know the gas, but I think this is everything I have. I'm looking at my notebook. I don't think, yeah, this is basically what you can do. This is everything. Okay, so now that we covered Charles' Law, kind of, hopefully you guys understand. We're gonna move on to question time. Okay. So question's gonna consist of finding the one. I'm gonna have 2 or 3. I'm not sure. One is gonna be finding the volume, and one is going to be finding the temperature. We did the temperature. I purposely didn't do the volume, so you guys could have a challenge to do. And yeah, we'll meet you on the question side. Bye bye. Okay, so now that you may have familiar okay, forget about that. Now that you've understand Charles' Law, hopefully, if you don't, you can join my Discord, get some help or whatever, blah blah blah, or you can watch the video again. It doesn't matter. So the first question and the second question, you might want to pause the video and do it, and then unpause the video and see if you got the answers right. So let's let's do the first question. If I have a 5-liter balloon that is at a temperature of 40 degrees Celsius, how hot will it be if I pump another 11.5 liters into it? Now, I'm gonna write down the formula. V1 over T1 equals V2 over T2. Now, we're gonna substitute the numbers in. So V1 is 5 liters over T1, which is 40 degrees Celsius. Now, 40 we only accept Kelvin, so we have to convert 40 degrees Celsius into Kelvin. Now, I already have it prepared. So we use this formula called TK. No, not called TK, but TK equals TC plus 273.15. Now you see the dots? Just ignore the dots. This is my second try doing it, and I forgot to delete it. Okay, so now you also want to have the point 15, yeah, because that point 15 can mess up your whole experiment. Well, sometimes, but a little dent, like in the experiment, it's all gone. For example, like you need 1 drop of maybe hydrogen. Like that's not possible. 1 drop of maybe water, H2O, and then you accidentally drop 1 and then a bit more, and that could mess it up. You know, it won't explode or something. I don't know. Okay, so anyways, let's continue. And then TK, the Celsius is 40 degrees because we want to convert that into Kelvin, plus 273.15, and then TK would equal to 313.50 Kelvin. Now, after that, we can use that number instead. 313.15. And that's equal to V2, which is 11. The question said, how hot will it be if I pump another 11.5? So it's not 11.5 liters, but you pump another 11.5 liters from the 5 liters. Does that make sense? So you're going to add 11.5 with 5 liters, and that will give you 16.5 liters. So 16.5 liters over 3, not 3, over T2. That's what we're finding. Now you're gonna cross multiply, so this one first, and then this one. Actually, no, that doesn't make sense. This one, and then this one. Now grab a calculator. 313. No, that's 303. 313 times 0.15 times 16.5. Ignore my sister crying in the background here. That is 5. No, that's blue. 5166.5 0.975 is equal to 5 multiplied by T2. That's a period. Wait, dot T2. Now you're gonna divide 5,166.975 with 5. Okay, so 5. I should have deleted it. 5.975. Gonna divide it by 5. That gives you a total of 1,000. So T2 is 1,033.95. And remember, it always has to be Kelvin. So our final answer is 1,333.45. No, 95. Sorry, 95 Kelvin. You got the answer. Congratulations, you got it right. If you didn't, you always learn from your mistakes. Next question. If I have a 200-liter balloon with a temperature of 522 Kelvin, what will be the volume when I heat it up another 200 Kelvin? Now I'm gonna write the formula again, and this time red. Actually blue. Just make it smaller. So V1 over T1 equals V2 over T2. Okay. And I'm gonna circle it in red. I know it doesn't make any sense, but you know, I'm gonna use all the colors I have. Next is we're gonna substitute the numbers in. So V1 is 200 liters because that's the first balloon. 200 liters, and it's kind of like comparing, but like in a mathematical way. So let me get to the point. 200. Yeah, actually, you can just write 200, and then 522 Kelvin, which is the T1, and then we're gonna find the volume, so we're gonna keep V2 empty, and then the T2 is 200 Kelvin. Actually, it's not 200 Kelvin if you think of it, because you're gonna heat up another 200. Because it's not, you're heating up another 200 from 522 Kelvin. So you're gonna add them together and you get 722 Kelvin. Now you're gonna cross multiply this with this. So 200 times 722. That is equal to, that's a big number. 144,400. If you can pronounce that, I don't think. It's 144,400 Kelvin. No, not Kelvin. No, volume. Okay, it doesn't really matter for now. But and then we're gonna do 522 times V2. You're going to divide them. Sorry, and then you're gonna divide by 522. And that gives you a temperature of 276. Not temperature. Sorry, volume. Oopsies. So V2 is equal to 276.628. Should I write the whole thing? If you want the whole thing down, like if you want it to be like point exact, not point exact, but like, I know this is the volume. But if you don't need this, you don't necessarily need this. You can just use this. Or you can also use it as like 27.663. It doesn't really matter. You can use this whole thing, or this one. In experiments, I would use this one. because I'm not sure how you're gonna get like 0.835, no, 0.00835525 liters. I'm not sure how you're gonna get that, so I just use this one. Delete, 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 delete. So if you got this answer, or somewhere near, or this answer, or 276.63, you got it right. Good job. And now that's gonna wrap it up for today's video, as well as the question section. So if you did learn something, you can always like the video. I'm not gonna beg you to do anything or subscribe. It doesn't really matter if you don't. At least you learn something. You know, my goal is to make the world a bit smarter. You know, because why not? And hopefully you guys enjoyed. I'll see you in the next one you watch. I don't know when. Maybe a day, a month, a year. I don't know. A few seconds. I don't know. I'll see you. Bye.